Hello everyone, today we're going to talk about relay module. We will reverse engineering a relay module. As you know, relay module are electrically operated switches. So we will go through some introduction on this module and use of these relay modules. We will check the diagram and we will construct it. So as you know, relays are electrically operated switches, but relay module is same as that. Relay module is a set of electrical components like diodes, like resistors, like LEDs, and they are mainly work based on a signal. The signal can come from a Arduino board, it can come from an application, a transistor, or anything, or it can come from circuit board and it will trigger the relay. So where they are used? Well, relay modules are used in many applications like UPS, cars, machines, factories, and fuse box. So relay switch. This is the relay switch diagram. How it works. It has a magnetic. It has a coil inside of it. So when current pass from this magnetic coil, it get magnetized and it will trigger this arm, and it will push this pin and it will connect to other pins. So it has three pins. One is normally closed, one is common, one is normally open. So the normally open is normally open, but the normally closed are connected to common and normally closed. So when we give current, so it will trigger this arm, and it will close the connection between normally open and normally uncommon. So here is the physical shape of it. You see it says open and it has a coil and it has a mechanic system. The relay module diagram is more like this. So this is the relay switch. We have a positive and negative connection here. We have a signal here. We have some diodes and transistor and LEDs. So this relay is a 5-volt switch. This is activated by 5 volt, and it can carry voltage on up to 250 volts, 10 amp, and these are the three pins for connection, normally connected, and common and normally open. And this is the power for the relay. It can be, because it's 5 volt, you need to connect 5 volt here. If you connect a lower voltage, it will not work. If you connect higher voltage, you might burn this board and relay. And this is the signal input, so signal comes from this. And same here is the actual model of it. Okay, so this is the signal comes here, positive and negative, and this is the normally open, common, and they normally close. So let's draw this circuit diagram on a software. So to draw this, I use this software called Circuit Wizard. It's a student edition. You can download this, Google the Circuit Wizard, and you can download it. So I will start by placing a relay switch. This is my relay. So and we'll rotate this way. This is my relay diagram, and now I will place power for this relay. Where I get the power is the power supplies here. So because it's 5 volt, what I do, I connect a 5 volt power supply. So this is 9 volt battery. So double click on it, set the voltage to 5 volt. So I go and connect the first pin of the relay to this battery. Okay, so and now we use a transistor called NPN transistor. So I will look for a transistor. Where are transistors? There are transistor. This is my NPN transistor. So remove this wire and put the transistor this side, flip transistor this way, connect the negative pin to transistor here, and this will go to this pin of the transistor. Directly connect the positive pin to the relay. So right now we have, this is the common wire and this is the two naturally closed, normally closed and normally open wire of the relay. So what we need to do now, we want to put a LED to say our relay is on. So for that we need an LED. Let's find an LED. Light emitting diode, so LED. So put it this way. One connection come here and other connection come here. We can't directly connect this LED to this wire because the LED will explode. So I will remove this wire. We need to place a resistor from 100 ohm to 470 ohm, because this is a 2.5 volt resistor and it will explode. It will not work, it will burn. Draw a wire here. Let's draw a wire from here to here. So we place our LED, we place the resistor, we place the relay. Okay, so we can draw a signal wire here. For that we assume, what we do, we put a switch. Let's find a switch. Switch is here. So we place a switch and we will place a resistor to give a signal to the, we will give a signal to transistor. So our resistor will be, this resistor will change the value to ohms. I'll put 470 ohm, and this resistor same 470 ohms. Okay, let's rotate this one, place it here. Okay, this is our signal wire and this is our switch. What I do, I give a signal, I give a voltage which is a signal, it will act as a signal to turn on this relay. So let's see, look at this connection. Let's play this let's do a simulation. Push this. You see, when I push this, you see the current goes, moves, and you see this switch. It trigger the switch, it connects to this normally open. Push this. Yeah, I think I have to change the direction of my LED. For that, let's stop this. I made a mistake here. So what I do, I'll put another LED this way, and let's connect this one here. Draw a wire here. Okay, play this, push this. Yeah, I made a mistake by placing the diode in wrong way. So this is our relay module. This is our signal pin, this is our common, and this naturally open and close. If you want to test this relay module, this is our application. Let's draw an application. The application has a resistor. We assume we want to turn on this LED. We want to work on this LED. So this LED is another application, and this LED has its own battery, own circuit. We make this 5 volt. and we'll connect this here, but we will not make this connection. What we do, we draw a line. Let's move this all this way, move this way, and here. Okay, we connect this to the common port of this relay, and we will draw a wire from here to here. So if we, as you see, we play this, we start simulation, and this LED is not turned on because it's normally open. This relay does not allow the current pass through, so what happens, this LED will be off. This is our application, this is our relay module. So let's turn on our relay module. You see the relay module is on, and this application, which is, this is our application, it will turn on, and you can see clearly the current goes from that way. So one more thing you need to consider is placing a flyback diode here. The reason we put a flyback diode is because the relay module is, the relay itself has a coil. Each time we turn on the switch and off, there will be voltage, high voltage spike like 200 volts, and that spike will damage our circuit board, that will damage our button, maybe this resistor, an LED. So for that we place a diode, a flyback diode. It can be IN4001. So we place this in parallel to relay. Okay, and here. So let's play the simulation. As you see, the diode works well, and this is our circuit board as tested circuit board. You see the simulation works fine. Remember, our relay module is here. Let's stop this. This is our relay module, and this is our application. Okay, so let's construct this. For that, what I do, I will use another software which called this FirstSync. I recommend this software. You use this one as well. So this software is a free software, open source. The other software was I was using this free version of it, which is a student edition. So on FirstSync we will place a relay, not this one. Yeah, place this relay, and okay, so in same time when I place my LED, I come here and I will place my relay module, relay switch, press relay, place it like this. Well, I need to make a hole because this relay is not going in, one of the pin is not in right location. Power supply. Okay, so let's place this. So second thing is, as we draw here was a battery. We don't need to put a battery, we use a terminal. So next thing I want to place is diode. So let's start placing diode. The diode has to be in parallel to relay. Okay, so this is our relay module with the relay with the diode. And now let's place an LED. And a resistor, the value I will put as a 470. So what next we need to do? We place this, we place resistor, we place the relay, place a diode. Okay, now we place a transistor, an NPN transistor. Okay, one more thing we need to do is to, yeah, I was right. So now what I need to do, we need to place a resistor for this relay, for this transistor. So I will place a diode in parallel to this relay. Okay, so we place the relay, we place the diode, we draw these two wires, and now we are going to place this resistor with this LED. So let's place our resistor. We have very less space here, so I will try to place it here. So that's the best location. We done with the resistor. Now place LED. Connect this LED. So our LED is done. We done with resistor, LED, diodes, and relay. Now it's time to place our transistor BC547. So place it like this. Okay. Now this pin is done, and now time to connect this resistor. Remove this one. Negative and the positive. Yeah, let's see if we can change this to one pin. Whole diameter pins. Okay, it can be 2, and let's make this 3. And okay, now we are okay. We remove this one, remove this one. So we draw one wire from here to here. This is a positive connection. This is a negative connection. And this is our signal. So now we're okay. We need one more terminal for the output connection. So this is common wire places here. This is our naturally open, normally open, and normally closed wire goes here. So this is our complete sketch for our relay module. And you see the other one is here. We can check it again. This simulation is the relay module. So from here, and this is our application. It can be anything. This switch can be an Arduino board can give a signal. It can be an application, it can be a signal, it can be anything. But I connected to 5-volt power supply and connected a resistor to give it a signal, and this transistor turns on. Stop this one. Let's go back to our schematic. Okay, I will continue placing my components on the PCB. So here is our completed relay module. We need to make this small. We need to saw or cut the PCB to the size of the relay module. Here, as you see, we cut the edges of the PCB. We cut the extra piece of the PCB, and we have our relay module working. Thank you everyone for watching my video. Press like if you liked it. Please share and subscribe. So until next project, have a good time.